If the body is in the motion, it will try to remain in the state of motion only. And that property is known as what? Inertia. Is that clear? If a body is in the state of rest, it will be in the state of rest. And that property is known as inertia of rest. Clear? Okay. So, any other question till this point? Any other question? No? So, we have discussed about the force also as isn't it? What do you understand the term force? What do you understand the term force? What is a force? Sorry. Let me teach you the word. You're going to something else. What's mean force? Force is any external agent which can change the state of the body. It can change the state of body. If a body is in the state of rest and bring it to the state of motion, that external agent is known as force. Is that clear? Okay. So, here, talking about the force, this force is of two different types of force. We can get two different types of forces. Okay. There are two different types of forces. The first one is your contact force. First one is your contact force, contact force. The force which comes into play by actual physical contact. If there is actual physical contact between the two bodies, then that type of force is known as contact force. For example, weight, normal reaction. Okay, if you see that this contact force is of 5 different types of contact forces are there. 5 different types of contact forces. First one is your normal reaction. Weight, tension, force due to collision, and force of escape. So these are the 5 different types of contact forces. Weight of a body is a contact force. Normal reaction, contact force. Force due to collision, contact force. Okay, force of a spring, contact force. And last one is your force due to collision. Okay, so when the two, what is force due to collision? When the two bodies collide, that is the force of collision. Force in a spring, whatever force a spring has, that is a force of spring. Whatever weight I am pressing the ground, that is the weight of my body, and it's also a contact force. Right? Because the floor and my body is in direct contact, direct physical contact is there. Right? So that's the contact force. And another type of force is your non-contact force. Another type of force is your non-contact force. Non-contact force, the force which comes into play. The force which is applicable on another body without any physical contact. Without any physical contact. Right? For example, say a chalk is here. If I give this chalk, then the chalk will fall. Why? Why does the chalk fall? Because of the force of gravity. Right? So that means the gravitational force is a contact or non-contact force. Non-contact force. Because earth is applying the force on this chalk without making physical contact. Without making a physical contact. Right? So I am just giving this chalk here. Chalk will fall. Why? Because the force of gravity. Right? Earth is applying the force of gravity without actual physical contact. Okay, so that's why it's called charge. If I place a two magnet nearby, what we can see? Either we can see the force of attraction or we can see the force of repulsion. Right? We can see the force of attraction or force of repulsion. Even if we see the repulsion or attraction, a magnet will never touch each other. Isn't it? Right? If a repulsion is there, here gravitational force, magnetic force, electrostatic force. Electrostatic force is also like a type of a magnetic force. Only difference is there in magnetic force. Two magnets will be there. Electrostatic force, two charges will be there, plus and minus, or plus, two charges will be there. So plus repair, minus repair, plus minus. Is that clear? Right. So that is what is known as electrostatic force. Right. So there are non-contact force. Examples: gravitational force, magnetic force, electrostatic force. These are the three non-contact forces. Clear? Okay. So these are there in the Newton's first law of motion. Any question from Newton's first law of motion? Any question from Newton's first law of motion? Anyone? No? No question? Okay, so this is the Newton's first law of motion, right? No question, no? Anyone? Okay, any question? Yes? This is the question. Ask. I guess we have one solution. Okay, fine. So that's Newton's first law of motion. Is that clear? So now let's move on to the second part of this. That's Newton's second law of motion. By the way, from Newton's first law of motion, what are the two things that we are going to get? Definition of force and definition of energy. Okay, the definition of force and the definition of energy. Definition of force and definition of energy. These are the two things that we are going to get from Newton's first law and Newton's second law. Okay, Newton's second law. Before understanding the Newton's second law again up here, first of all we need to understand what is the term momentum is. Right? What is the term momentum? Momentum. Now momentum, what does momentum means? See, momentum is represented by, first thing it's represented by letter P. Like force is represented by letter F. Similarly, momentum is represented by letter P. Okay, momentum is represented by letter P, capital P, right? So what is momentum? Momentum means it is the product of mass and velocity. Product of what? Product of mass and velocity. So that means if I multiply mass and velocity, then what I am going to get? Momentum. If I multiply mass and velocity, then I am going to get what? Momentum. Good. Okay. Momentum is a vector quantity, right? Momentum is a what quantity? Vector quantity. What do you understand the term vector quantity? Momentum is a vector quantity. What is a vector quantity? What is a vector? Yes, please. Very good. This contains magnitude and units. Okay. So this is vector quantity. Here, so the SI unit. SI unit of momentum is what? kg meter per second. The SI unit of momentum is kg meter per second. Right? So here, Newton's second law says. Newton's second law says. Clear with the momentum? Clear with the concept of momentum? So Newton's second law says that the force that's been applied to the body, whatever force you apply to the body, that force is directly proportional to the rate of change of momentum. Okay, dp by dt means rate of change of momentum. Okay, right? dp by dt means what? The rate of change of momentum. That means dv means the change in the momentum, dt means change in the time. So the change in the momentum divided by the change in the time is known as the rate of change of momentum. Right? So dp by dt is the rate of change of momentum. Right? If I say dp on, if I say dp on, what does dp means? Change in momentum. If I say dt, what does it mean? Change in time. Okay? So this is your change. Change in momentum, and this one is your change in time. So if we divide these two, then what we call rate of change of momentum, right? If we divide these two, that means dp by dt. If we divide this two, that is known as rate of change of momentum. It's the rate of change of momentum, right? So Newton says that whatever force you are going to apply, that force will be directly proportional to the rate of change of momentum. Okay, rate of change of momentum. And since we said that it's a vector quantity, then there should be some direction, isn't it? There should be some direction. What will be the direction? Direction will be in the direction of the force. That means the change will take place in the direction of force. In whichever direction you are applied the force, the change will also take place in that particular direction. Right. So say that if I apply the force to this book, right, I'm applying the force from left to right. The book also changes in the left to right. Right, because the direction is from left to right. Is that clear? I apply the force from left to right, so the book also changes from left to right. Okay? Right, so the rate of change of momentum is directly proportional to the force applied. Right? It's directly proportional to the force applied. That means more the force, more will be the rate of change of momentum. Lesser the force, less will be the rate of change of momentum. Clear? So if this proportional sign is being removed, then we need to write some constant, and here our constant is a k, and dp by dt. What does k stands for here? K is constant. K is your constant. Okay. Newton chose this constant in such a way. Newton chose this constant in such a way that the value always remains fixed and it is numerically equal to 1. Okay? Whichever unit you choose, whatever may be the dimension, it always remains as amongst 1. Always remains as 1. Okay? So from here, from this expression, we can say that rate of force will be equal to dp by dt. dp by dt. Now, from this definition of momentum, we can say that momentum is equal to mass into velocity. Okay, momentum is equal to what? Mass into velocity. Out of this mass and velocity, which one is constant? It's mass or velocity? Which one is constant? Yes? It is the mass. Okay, mass is always constant. We know that. So you can take this outside. Now what is this? Like this is the rate of change of momentum. Now what will be this? Rate of change of velocity. What is the rate of change of velocity known as? Acceleration. Okay, rate of change of velocity is known as what? Acceleration. Acceleration is represented by letter A. Okay, so this is the formula of force. Right, this is the formula of what? Force. That force is equals to mass into acceleration. Okay, so like from Newton's first law, we are getting the definition of force as well as the definition of inertia. Similarly, from Newton's second law, we are getting the expression of the force. That is the formula of the force. We are getting it from the formula of the force. Right? And formula of the force is mass into acceleration. This force is equal to mass into acceleration. Here, okay. Who gave the concept of force? It is the Newton. Right? Who gave the concept of force? Newton. So, in his honor, the SI unit of force is Newton. Right? SI unit of force is what? Newton. In fact, if I say if I go to the detailed format of the SI unit of the force, then it is the SI unit is kg. It's the kg because mass, the SI unit is kg, and then the second one is the acceleration. SI unit is meter per second square, and this kg meter per second square is known as what? Newton. So that is your 1 Newton kg meter per second square. 1 Newton is equal to kg meter per second square. Right? Yeah. So whenever we write Newton as the unit, whenever we write Newton as a unit, Newton is the name of a person also. Okay? But if we are writing this as a unit, then we have to write. If we want to write the full spelling, then the first thing should be the small letter or just simply a capital letter N number. That is the symbol, right? This is the rule that if you want to write the full spelling, all should be the small letter or else capital N number, right? Here as a unit. Now, SI unit of force is what? Newton. So what do you understand about 1 Newton? 1 Newton is the force. 1 Newton is the force which acts on a body of mass 1 kg. Okay? 1 Newton is the force. So, 1 Newton is the force which acts body of mass 1 kg. Okay, 1 Newton is that force which will act on a body of mass 1 kg, produces an acceleration of acceleration of 1 meter per second square. Okay, produces an acceleration of 1 meter per second square. So, if there is a body of mass 1 kg, okay, if there is a body of mass 1 kg, and if that body can produce an acceleration of 1 meter per second square, then that is known as what? 1 Newton. Is that clear?
Yes, right.